Awesome. So let's do a unit conversion review. So in this course, we will be converting between units quite often. And it's something that you're going to want to feel pretty comfortable with and, just moving forward be okay with so that you can do the physics. I'm going to teach you two different ways of doing this. Unit analysis is the best way. I really like unit analysis. If you've done stoichiometry, it's the exact same thing as stoichiometry. And then I will show you a quick, cool little one-step method of converting within the metric system, which is a lot of times what we do, kilometers to meters, centimeters to meters, and things like that. Unit analysis is all about following the units, right? And canceling units. So it all comes down to the idea that if in a fraction, you have 9 over 9, anything over itself cancels, right? Reduces to 1. So we are going to use this idea when we do unit analysis. So the first question, I will show you how we're going to get it done here. It's 63,425 seconds, and we want to convert that into days. I want to know how many days that is. So what we can do is, well, let's start with 63,425 seconds. Maybe I'll write the units in blue. That's not blue. Seconds. We want to change that seconds into days. So what we're going to do is we're going to multiply this by a conversion factor, or maybe 2 conversion factors, or 3 if we need it. We can multiply it by as many conversion factors as we want to. So what we can do is we're going to multiply this by a conversion factor. It's going to be a fraction. I'm not even going to worry about numbers right now. It's unit analysis. We are going to analyze the units. So if you want to imagine the 63,425 is on the top of its fraction, right? If you want, you can imagine it as over 1. It won't make a difference, but you have seconds in the top. You want to get rid of seconds because you want to convert that to days. So in order to cancel that seconds out, you want to put seconds in the bottom. And you got to create the path to days. I don't know how many seconds are in 1 day, so I can't use that conversion, but I can do seconds into minutes. I know that one. And then I can multiply by another conversion factor. I don't want minutes. I want to cancel minutes out. So I have minutes in the top. I'll put them in the bottom. Minutes into, I don't know how many minutes are in a day. You could look it up and use that if you wanted. But off the top of my head, I know how many minutes are in an hour. But we're not quite there yet because we want to get to days. So let's do, this is 3 conversion factors. That's okay. Because now I can say, well, I want to get rid of my hours. I have an hours in the top. So I'll put an hour in the bottom, and I know how many hours are in a day. So I can put those together. 3 different conversion factors, no numbers yet. We are doing unit analysis. So watch what happens now if I do a cancellation of my units. So just looking at the units, seconds over seconds cancels out, minutes over minutes cancels out, hours over hours cancels out, and I'm left with days. And that's what I want. So before I've even done any math or put any numbers in, I know that this is the correct conversion. Now you can go in and put the numbers in. And the numbers you're putting in need to equal 1. And what I mean by that is, in 1 minute, we have 60 seconds. That's the same amount of time. That's the same value. So this whole thing right here, this whole fraction equals 1. Does that make sense? Right? Because you can't multiply by anything else, or you're going to change the value of 63,425. We don't want to change the amount of it. We want to change the unit. So we have to multiply by 1s so that we can change the units without changing the value, if that makes sense. So if you wanted to, just for argument's sake, you could, instead of putting 1 over 60, you could put 2 over 120, because that's also the same value. It's just easier to put 1 over 60, right? We know that it's a lot easier. Well, we also know that in 1 hour, there's 60 minutes, and in 1 day, there's 24 hours. So we filled in all of our values. We know it's going to be in days. And now what we can do is multiply everything across the top and then divide that by everything in the bottom. So in this case, I have 63,425 multiplied by 1, multiplied by 1, multiplied by 1. So what this really looks like is 63,425. We don't have to multiply it by 1 because it's not going to change the value. All divided by 60, multiplied by 60, multiplied by 24. You don't have to show me this step. I just want to show you what's actually happening. I always just multiply everything in the top and then divide everything in the bottom. And I had an answer, but I will recalculate because I can't remember. 63,425 divided by 60 times 60 times 24. So that comes out to be 0.73 days. There's a little bit more there, but that's okay. Does that make sense? That was quite a big one. But hopefully that makes sense. So just following the units first and then filling in the numbers. Let's do another one. 5 kilometers per hour into meters per second. This is a really common one in physics. We do a lot of kilometers per hour into meters per second and vice versa. Because in physics, we end up using units kilograms, meters, and seconds. Those are what we want to leave our answers in. Most of the time is either kilograms, meters, or seconds, or some combination of those ones. So in this case, we have 2 units. We have 5 kilometers per hour, so we have kilometers and hours, and we're going to convert that into meters and seconds. So the easiest way to write this is 5 kilometers, and that's in 1 hour, right? You don't have to write that 1 hour, but it's important that you write the units as hours in the bottom, kilometers in the top. That's what's happening. It's kilometers per hour. Now we're going to multiply by our conversion factors. I'm not sure how many there are going to be, but the first step we're trying to do is convert kilometers into meters. So we can deal with that. I have kilometers in the top to begin with, so I want to put kilometers in the bottom to cancel it out, and meters in the top. I know that one by heart because I've used it so many times. Hopefully you start to memorize that. In 1 kilometer, there are 1,000 meters. It's always the case. Kilo means 1,000. 10 to the power of 3, we'll talk about that later. So I've dealt with the kilometers and meters. Now I want to deal with the hours and seconds. So I'm trying to turn hours into seconds. You'll get used to knowing how many seconds are in an hour. But until then, what you can do is say, well, I have hours in the bottom here, so I need to put hours in the top. And I know how many minutes are in an hour, so let's use minutes for now. And I want to get rid of that minutes and convert that into seconds, because in the end, I want seconds, not minutes. So if I have a minutes in the bottom, I'll put a minute in the top and a second in the bottom. Now we can do some analysis, right? Kilometers over kilometers cancels. And you have to be careful with minutes. Minutes and meters use the same value. So M, small m represents meters. MIN would be your minutes. So then we have hours in the bottom over hours in the top. Minutes in the bottom, minutes in the top, so they cancel. And the units you're left with are meters per second. It's the only ones left. So we know our answer is going to be in meters per second. We just need to fill in those values. I know that there's 1,000 meters in 1 kilometer. I know that there's 60 minutes in 1 hour, and I know that there's 60 seconds in 1 minute. So when I go to do this calculation, I'm going to go 5 multiplied by 1,000, all divided by 60 times 60. So 5 multiplied by 1,000 divided by 60 times 60 gives me 1.388. I'll round to 39. 1.39 meters per second. That's unit analysis. You can convert anything. You can do it in 1 step. You can do it in 5 unit conversions, however many you need. It's important. I think it's a really good skill to follow the units first, then fill out the numbers. A lot of times in physics, if you're not sure of what you just calculated, you can look at your calculation. You did a meters divided by a second. So you must have meters per second in your answer, right? You can analyze the units to figure out what's going on. Converting within metric. I'm going to show you what I think is the easiest way to do it. You might have been taught differently. If you like doing it differently, it's going to get you the same answer, and that's totally fine. So here are your metric prefixes. You have this on your formula sheet as well. So mega is 10 to the 6, kilo is 10 to the 3, hecto 10 to the 2, deca 10 to the 1, deci 10 to the negative 1, centi 10 to the negative 2, milli 10 to the negative 3, and micro 10 to the negative 6. They go larger and smaller. But for now, those are the most common ones. So what that means is if you have 5 megameters, that big M means mega, then you can come over here and say 5 megameters. How many meters is that? Well, it's going to be, we see that mega is 10 to the power of 6. So that's 5 times 10 to the power of 6 meters. That's what mega represents, like megabytes or megapixels or Mega Man. There's 10 to the power of 6 men. That's a lie. I just made that up. That's a terrible joke. Can we cut that from the record? If you have 12 micrometers, how many meters is that? Micro is very, very small. So we can come over here and say micro is 10 to the negative 6. So that is 12 times 10 to the negative 6 meters. That's not proper scientific notation, but for the sake of unit conversions, it's the fastest way to just do it and then get your answer however you need. So it's easy using the prefixes to switch anything into the base unit. This works also for grams and for liters, right? Kilograms, milliliters, things like that. So your base units are meters, seconds. What did I just say? Grams, sorry, not seconds. I'm all confused. Meters, grams, and liters are your base units, and that works for anything, just like with those three. Does that make sense? What can be tricky is converting from, for example, from kilo to centi, like 3 kilometers, to centimeters. And there are ways to read how many jumps you're doing on here if you're going from kilo down to centi. But I find the easiest way to do this conversion is to first, before you even do any math, convert 3 kilometers into meters. We know that kilo is 10 to the 3, which means 3 kilometers is actually equal to 3 times 10 to the 3 meters. So the first thing I did was just convert 3 kilometers into meters without even doing anything. I just put the power of 10 on the end, right? We use that from the prefixes. And now you can multiply your conversion factor like we did with unit analysis, because we want to go from meters to centimeters. So we know, well, there's a meters in the top, so I'll put a meters in the bottom. And I'm trying to go to centimeters. And we can actually pull this unit conversion right from our prefixes, because we know 1 centimeter is 10 to the negative 2 meters. We picked that up from right here. So what's really happening here, you don't have to show me this step, but I will just rewrite it. 3 times 10 to the 3 over 10 to the negative 2. And hopefully you all remember when you divide exponents with the same base, or divide powers with the same base, what do we do with the exponents? Do you remember? We subtract them. So what we're doing is saying 3 times 10 to the power of 3 minus negative 2. 3 minus negative 2? Well, when we subtract a negative, it's like we're adding. We can chop, chop. So it becomes 3 to the power of 5 centimeters. So 3 kilometers is 3 times 10 to the 5 centimeters. So the first step is just kilometers into meters. and then switch that meters into centimeters. So always return to your base unit. I find that a lot easier. My brain works in steps. If you like to do it all in one step, absolutely do that. But I find returning to the base unit always helps me reduce my errors, reduce my mistakes. Pause. Nope, I don't know how to pause this. This will be in the video. That'll be fun. So I thought I knew how to pause. I don't.